Well, I just had a washing machine, a Maytag, um, basic top load washing machine. Stopped working after 9 months, and I traced it down to the motor wouldn't turn. It would just kind of buzz, but it wouldn't turn. I traced it down to this capacitor. It's the motor start capacitor. And when I measured it, it didn't measure the 50 microfarads that it's supposed to be. But why did it stop working? This thing is somewhere between retail $50 to $80, and seems overpriced considering you can buy a air conditioner motor start capacitor 50 microfarads for $11 to $15. They do show this interesting thing on here that this is a 50 microfarad and then an 80 microhenry inductor inside. And these are also what they call protected capacitors. Supposedly there's some kind of overload or overpressure switch inside here that stops it from working. I'm just curious why they failed. Is that inductor really in there, or is that like parasitic inductance inside here? This was held on by a metal bracket, and this case is dented in a little bit by the metal bracket. Could that have caused the guts to short out or something? So I'm going to see if I can get it apart and see what's in there. Let's go to work. So it looks like there's a crimp on here. A can opener wouldn't really fit on there, so we're just going to try brute force. And if I can keep it in the thing, I think it's going to work because it's coming loose already. All right. Maybe we'll go a little tighter in the vise. There we go. Let's see if I can do it left-handed so you can see. Probably I can't. I'm no lefty. Yep. It does say there's like some kind of oil in here. Some of them say vegetable oil. So let's see if I can catch. What'd I lose? My hammer? No, I didn't lose my hammer. Or it says, other ones say different kinds of oil. Used to be PCBs, but I guess they don't use those anymore because they're like toxic. Squirting out the other side. Okay. Are we still in the field of view here? So we've got, all right. So we've got some little tabs that can connect up to the top tabs here, so they can assemble it, they can fold it over. They probably spot built the capacitor and then spot welded those. It looks like there's a little spot weld on there. All right, let's see if I can get this rest of this thing out of here now. There, we're getting it out. Holy shit. There's actually an inductor in here. So I don't know what I see here. There's these little hairy things on the side here. I don't know if that's actually metal that was shorting out to the case here. I can't tell if it's just plastic, but like there's brown spots on this one, like there could have been a little bit of electrical arcing. So here it looks like the bottom of the capacitor, stacks of something, an insulated conductor that comes up through the plastic here. This would have been the top of the capacitor. This looks burned to me, so this could have been where it failed, like this separated from right here. But this is actually a coil of wire. So if I take this yellow tape off, we're going to find, can I do it? Can I get a hold of it? Yep. And there she is. That's a knife, so we can cut this. So yep, it went from the top of the capacitor to this inductor and then up to the other terminal. So it is what it showed. There actually is an inductor inside the can. To me, it looks like it unsoldered itself. Maybe it overheated, or maybe it was never soldered very well, spot welded there. And then I guess I'm also wondering if, let me look at the inside of the can and see if I can see any electrical arcing from these little feathery things, if it went to the can or something. I don't know, would that matter? It might matter. These seem to be, the terminals seem to be isolated. All right, we got that. I'm gonna wipe my hands off a little. Well, okay. The inside of the can there is a plastic insulator in there, so it can't touch the can side directly. I don't know if you can see that plastic thing right there. More of that brown gunk in there, gray stuff. And if I can find something to pull this plastic insulator out. There's that. I can't say, if this is bad or good. All I can say, it was insulated and it was floating around in that gray gel, gray oil. And way down in the bottom, just this little plastic thing that's in the bottom that helps keep that capacitor centered in there. So I guess it was kind of insulated. They talk that it says it's protected on the can here. It says 50-60 hertz protected 10,000 AFC, and that's something like I looked it up. Something about amperage. I can't remember now. They talked about it being like overpressure. I don't see like a pressure thing in here. The only thing that's suspicious to me is that this wire, this inductor wire, which part of it still seems to be soldered here, and can I get it back? And yeah, this is what failed, because there's part of the inductor wire soldered on. It's burned. It's no longer there. You know, why did that fail? Did it break? Is this a failure of the overprotection circuit or a poor solder job? You know, was the wire bent back and forth? But I think we can see that that's why this thing stopped being a capacitor and an inductor. So I guess that's the end. The bottom line here is, I would say you could not go and buy a 50 microfarad HVAC air conditioner capacitor and put it in your washer, because it doesn't have this inductor in it, and they want it in there for something. An inductor limits the inrush current. That's what an inductor does, is it prevents what we call instantaneous changes of current. It slows it down so the capacitor charges, and would be a little less abusive on the motor for that. So the bottom line is, I guess you got to buy one that has an inductor built in to replace your washing machine motor capacitor. If it's got that on there, you better buy one that has that same thing. All right, I guess that's the end of this video.